Welcome back to the channel. Today, we're exploring an incredible innovation that could revolutionize the way we generate energy: space-based solar power plants. Imagine collecting solar energy directly from space and beaming it down to Earth, providing clean and limitless power. We'll break down how these futuristic plants work, their benefits, and the challenges scientists face. If you're curious about cutting-edge technology shaping our future, stay tuned and don't forget to subscribe for more amazing content. Number 5. Unlimited energy. Space-based solar power plants have the remarkable advantage of providing virtually unlimited energy. Unlike solar panels on Earth, which are affected by weather conditions, seasons, and the day-night cycle, solar panels in space can continuously capture sunlight without interruption. This means they can generate electricity 24 hours a day, 7 days a week, regardless of clouds, rain, or nighttime. The consistent exposure to sunlight in orbit ensures a much higher energy yield compared to terrestrial solar systems. Additionally, solar panels in space are not limited by the atmosphere, which absorbs and scatters some of the sun's energy on Earth. This allows them to collect more intense and consistent solar radiation. The energy harvested in space can then be converted into microwaves or laser beams and transmitted wirelessly to receiving stations on Earth, providing a constant and reliable source of electricity. This capability makes space-based solar power plants an ideal solution for addressing energy shortages and supporting growing global energy demands. By tapping into the vast and uninterrupted energy of the sun, humanity could achieve a near-limitless supply of clean power, reducing dependence on fossil fuels and contributing to a more sustainable future. Number 4. Reduced carbon footprint. Space-based solar power plants have the potential to drastically reduce the carbon footprint associated with electricity generation. Unlike traditional fossil fuel power plants, which release large amounts of carbon dioxide and other harmful greenhouse gases into the atmosphere, solar power in space relies entirely on sunlight. This means that the energy produced is completely clean and renewable, with no emissions during operation. By generating electricity in space and beaming it to Earth, these systems can replace coal, oil, and natural gas power sources, which are major contributors to climate change. Additionally, since solar panels in space are exposed to constant sunlight, they can produce energy more consistently than ground-based solar farms, reducing reliance on backup fossil fuel plants that often compensate for intermittent energy production. Over time, the widespread adoption of space-based solar power could significantly lower global greenhouse gas levels, helping nations meet climate targets and reduce environmental pollution. This shift not only supports a cleaner planet, but also promotes sustainable development by providing an alternative energy source that does not deplete natural resources or harm ecosystems, making it a crucial step toward a low-carbon future. Number 3. High efficiency. High efficiency is one of the most important advantages of space-based solar power plants. Unlike solar panels on Earth, which are affected by clouds, weather changes, and the day-night cycle, panels in space receive constant, uninterrupted sunlight. This continuous exposure allows them to generate electricity at a much higher rate. Additionally, solar panels in space are not limited by the atmosphere, which on Earth absorbs and scatters sunlight, reducing the amount of energy that reaches the panels. In space, solar panels can capture the full intensity of the sun's rays, which is about 30% stronger than what is available on the Earth's surface. This means that a smaller surface area in space can produce the same amount of energy as a much larger installation on Earth, making it a more efficient use of materials and resources. Advanced solar technologies, such as multi-junction cells designed for space, further enhance energy conversion efficiency. With higher efficiency, space-based solar power plants can provide a reliable, high-output energy source that could support large-scale power demands on Earth, making them a promising solution for future sustainable energy production. Number 2. Global energy supply. Space-based solar power plants can provide a reliable and continuous energy supply to virtually any location on Earth. Unlike traditional solar panels on the ground, which are limited by nighttime, weather conditions, and seasonal variations, solar panels in space capture sunlight 24 hours a day, 7 days a week. The energy collected is converted into microwave or laser beams and transmitted wirelessly to ground-based receiving stations, known as rectennas. This means that even remote or energy-poor regions, which struggle with access to conventional electricity grids, can receive a stable supply of power. It also allows countries with limited natural energy resources to reduce dependence on imported fuels, improving energy security and economic stability. Furthermore, space-based solar power can balance energy demand globally by sending energy to regions experiencing peak consumption, helping stabilize power grids and reduce blackouts. By linking multiple space-based solar satellites, it is possible to create a global network that ensures continuous, renewable energy for the entire planet. This capability makes space solar power a transformative solution for addressing worldwide energy challenges, while supporting sustainable development and reducing reliance on fossil fuels. Number 1. Future Energy Solution. Future Energy Solution refers to the potential of space-based solar power plants to provide a sustainable and long-term energy source for the world. Unlike conventional energy systems that rely on fossil fuels, which are finite and polluting, space solar power can harness sunlight continuously from orbit, ensuring a stable and reliable supply of electricity. This energy can be transmitted wirelessly to Earth using microwave or laser technology, allowing it to reach urban centers, rural communities, and even disaster-stricken areas, without relying on local fuel sources. As the global population grows and energy demand rises, traditional power grids may struggle to keep up, making space-based solar energy an increasingly attractive alternative. Moreover, because it does not produce greenhouse gases or contribute to climate change, it aligns with global efforts to achieve net zero carbon emissions. Advances in satellite technology, materials science, and energy transmission methods are gradually making this futuristic concept more feasible. Once fully operational, space solar power plants could revolutionize the way humanity consumes energy, reducing dependence on fossil fuels, stabilizing electricity costs, and offering a clean, abundant, and virtually inexhaustible energy solution for future generations. Thanks for watching and diving into the world of space-based solar power plants with us. The future of energy is closer than you think. Stay informed and inspired by subscribing to the channel for more exciting innovations and breakthroughs. Don't miss out. Subscribe now.